All right, this video is about antiderivatives. So we're going to start with a question. Find a function f whose derivative is f prime of x equals 3x squared. So what it's asking now is they're giving you the derivative, and what they want to know is what was the original function. So that is considered our antiderivative. So looking at this, you could probably already guess that, oh, well, if it was a 2, that means we had to start with an x cubed. And then that 3 will come down. And so now you can just check by taking the derivative. That would be 3x squared, and it checks. So this is our antiderivative. So for notation's sake, what we're saying is we have the derivative of f with respect to x, which is our f prime of x. This is now going to be called f of x. So this little symbol here is our integral, and we'll talk about that in the next chapter. But this is basically saying our antiderivative. So our antiderivative of f of x is basically saying we're taking the antiderivative of our derivative to get us back to the original function. So this up here. They're going to give you the derivative, and you take it back to what it was before. So to kind of get an idea of what that is, let's take some derivatives. So we have y prime equals 12x squared plus 4x, and then the constant would be 0. Y prime equals 35x to the fourth minus 6x minus 5, and then the constant becomes 0. Y prime equals negative 2x minus 3, and again the constant becomes 0. So this is what we're starting with now in this section, but it's going to look like this. It'll say f of x equals 12x squared plus 4x, or g of x equals 35x to the fourth minus 6x minus 5, or h of x equals negative 2x minus 3. And what they want you to do is find the antiderivative. And we're going to call that capital F of x, capital G of x, and capital H of x. So when you see these lowercase ones, you want to just think of them as the derivative in this section. So this would be f prime of x, g prime of x, and h prime of x. And we want to create our antiderivative. And so we already know how that works. This was our original function. This is our derivative. So we know that for 12x squared, the term that gave it to us was 4x cubed. So that would be 4x cubed. That would be 2x. And now you can't write 5. So this is the new thing. You have to put plus c, because we don't know what the constant was. Yeah, we do here, but in our problems themselves, when they give it to us and they ask us to find the antiderivative, we didn't know what the constant is. It's not given here. 0 just means that we had a constant. So there's always some plus 0 here, which will give us a constant. And I will explain all these rules in the next section. Right now it's just an intro to the idea behind it. So we know this would be 7x to the fifth minus 3x squared minus 5x. And then now we can add our constant. So all we're doing is taking our derivative back to the original function and then putting a plus c on the end. So it's 7x squared minus 3x, 7x to the fifth minus 3x squared minus 5 plus c. And so this one would become this, but instead of writing 5, oops, wrong color, we put plus c. And so this is what we're going to be doing in this section. We're going to be taking the derivative that they give us, but they won't be saying it's a derivative. They will be saying it's a function like f or g or h, and you want to think of it as f prime, g prime, and h prime, and we're just going to take it back to what the function was before, and this is our antiderivative. So let's try some in the next video.